All right, guys, today we talked about one-step equations again, but we talked about adding in what we're calling rational numbers. And all that means is that we're going to be solving one-step equations with fractions and with decimals, okay? So let's review our steps from yesterday because absolutely nothing is going to change except now we're going to be dealing with a little bit more complex numbers, okay? So first thing we need to review is what is a one-step equation. A one-step equation means that you only have to perform one mathematical operation to solve it. So you could add, subtract, multiply, or divide, but you're only going to do one of those operations to solve. So the types of problems we looked at yesterday were maybe a plus 34 equals 72, 3b equals 18, h minus 9 equals 66, y divided by 7 equals 14. We only dealt with whole numbers. Today, we're going to be dealing with these same types of problems, except our 34 might be a fraction, or it might be a decimal. We're going to add in our rational numbers, okay? So if you think back to yesterday, what we were trying to do, we were trying to isolate the variable and get it by itself, and we did that with inverse operations, okay? So quick review, inverse operations are operations that undo each other. They cancel each other out. So the opposite or the inverse to addition is subtraction. The inverse to subtraction is addition. The inverse to multiplication is division. And the inverse to division is multiplication. These cancel each other out or they undo each other. Okay. So a review of our steps, the first thing that we need to think about is that the goal of solving any equation is to get the variable by itself. Okay, you're going to hear me say isolate the variable. That means just to pull it apart and get it by itself and see what it equals. So to do that, the first thing that we're going to do is we're going to look at our equation and determine what inverse operation that we need to solve the problem. Okay, then we're going to perform that inverse operation to both sides of the equation. We talked yesterday about how equations say that two sides are equal. So whatever we do to one side, we have to do to the other so that our equation remains balanced. Okay, then last but not least, we're going to write our answer in the form variable equals solution. Solution is the answer to an equation. And so we want our our variable on the left and our solution on the right. Okay, so again, these are going to look super familiar. The only difference today is that we have fractions, we have decimals. Okay, so just like we talked about yesterday, the very first thing that we're going to do is draw our line through the equal sign to remind us whatever we do on the left, we have to come over here and do on the right. So I see a plus 3.2, and I want to cancel that out to get the y by itself. So I'm going to use my inverse operation of subtraction, and I'm going to subtract by 3.2. Whatever I do on the left, I'm going to have to come over here and do the exact same thing on the right. Now, I have a plus 3.2 and I have a minus 3.2. Those are opposites, so those are going to cancel, and we're left with just a y. And then over here we have 6.5 minus 3.2, which is 3.3. So our solution is y equals 3.3. Now, you'll see that I've got my little check mark down here, because what we can do is we can check every equation that we ever solve to see if it's right before we submit our answer. So we should never miss an equations question because we can check it with substitution. So what we're going to do is everywhere we see a y, we're going to substitute in our 3.3. So instead of y plus 3.2, we're going to do 3.3 plus 3.2, and we're going to see if that's equal to 6.5. So all I have to do is plug this into my calculator, 3.3 plus 3.2, and I get 6.5 is equal to 6.5. Since that is a true statement, we know that our solution of 3.3 is correct, that it's good, that it's perfect. Okay. All right, so let's look at our next one. We have p minus 1 1/2 equals 22 3/4. Again, we're not going to do anything different now that we're dealing with fractions. We're going to start by drawing our line through the equal sign and looking to see what inverse operation that we're going to use. I see a subtract 1 1/2, and so I know the opposite of that is going to be to add 1 1/2. That's what I need to cancel it out and get the p by itself. Whatever I do on the left, I've got to come over here and do the exact same thing on the right. So on the right, I'm also going to add 1 1/2. A minus 1 1/2 and a plus 1 1/2 cancel each other out, and I'm left with just my p, which is exactly what we wanted. And now I have 22 3/4 plus 1 1/2. Now, remember in class we talked about we can use our calculator for this. So I'm going to pull out my calculator and I'm going to type in 22 3/4 plus 1 1/2, and I get P equals 24 1/4. Okay, now that's my solution. I'm going to come down here and check it to make sure that it's exactly right. So instead of P minus 1 1/2, I'm going to substitute my P with 24 1/4. So we have 24 1/4 minus 1 1/2. And I want to see, is that equal to 22 3/4? So to do that, I'm just going to plug this into my calculator real quick. 24 1/4 minus 1 1/2. And I see that it's equal to 22 3/4, which is exactly what we are looking for. So we know that our solution, or our answer of P equals 24 1/4 is correct. All right, now on number 6 here, we have 3/4 K equals 1 1/2. A lot of people get tripped up on these types of problems because they see that division bar and they're like, oh, it's division. But if we look at it closely, 3/4 is the coefficient for K. So we know they're right next to each other. We know that that math operation is actually multiplication. Okay, so I'm going to draw my arrow through my equal sign. And I know to get rid of or to cancel out 3/4 times K, I'm going to have to divide by 3/4. So whatever I do on the left, I have to come over here and do the exact same thing on the right. And here we have a times by 3/4 and a divide by 3/4. So those are opposites, so they're going to cancel each other out, and I'm left with just my K. And then I have 1 1/2 divided by 3/4. Again, we can use our calculator to help us solve this, so I'm just going to type it in my calculator, 1 1/2 divided by 3/4, and we get K equals 2. Okay, so our solution is K equals 2. So we can check that super quickly by substituting substituting a 2 everywhere we see a K. So instead of 3/4 K, I have 3/4 times 2 equals 1 1/2. And so I'm just going to plug that into my calculator, 3/4 times 2, and I get 1 1/2 is equal to 1 1/2. Those are equal, so I know that my solution, K equals 2, is correct. All right, our last one, let's take a look at our division problem here. We have R divided by 0.784 equals 2.822. Again, we're not going to do anything different here. And we can use our calculator to help us with our decimals. So the first thing that we're going to do is we're going to draw our line through the equal sign, and then we're going to determine what inverse operation we're going to use. We see a divide, so I know I'm going to have to multiply by 0.784 to cancel that out and get the R by itself. So we have, whatever I do on the left, I have to come over here and do the exact same thing on the right. And I have a divide by 0.784, a times by 0.784. Those are opposites, so they're going to cancel each other out and leave us with just an R, which is exactly what we wanted. Then I'm just going to pop this in my calculator, okay, so we don't have to actually multiply out the decimals. We have 2.822 times 0.784. That gives us, holy camole, 2.212448. I'm so glad I could use my calculator for that and that I didn't have to work it out by hand. Our solution is R equals 2.212448. And we can check that easily by substituting our R with this nice big long decimal. So if we put this in our calculator, 2.212448 divided by 0.784, we see that we get 2.882, which is exactly what we're supposed to get. So that tells us our solution of R equals 2.212448 is exactly right.